So here is the addition running record. This first page here is the sheet that is the part one, which is the benchmark expression. So each of the strategies that research has shown is the best for the children's development. There's one expression for each of those strategies along the progression. So you can see where the slowdown actually happens. They're right in the order of the progression. So this is the sheet that would go in front of the students. That's all they would have. They're doing mostly mental math strategies here. So all you need is the paper in front of them. What I do is I tell the students, we're going to be doing a running record today. So first part here, we're going to go through some of these answers. I don't want them feeling pressured that they have to answer all of them if they're a young student. So I'll say, well, we'll answer some of these questions. And then we're going to go back to the beginning and talk about your thinking and how you figured them out. So this part one, I'm taking notes only if it's obvious, whether they're using their fingers. And I'm trying to see whether they're figure counting on, figure counting all, but it is more of an observation. I don't ask them in this part one, because part one, I'm trying to get a relative feeling of their speed and their accuracy, just to kind of get a sense of it. So I don't want to slow them down with asking them many questions in this part one. So then I'll say, okay, so what is 0 plus 1? And then they will tell me, and I'll be marking it on my sheet. I'll mention to them, I'll be taking some notes on their thinking so I can help them become even better at math. So this sheet just goes in front of them. Now in front of me, I have this code. This protocol. This is the recording sheet. So we have the name and the teacher and the date. Really important to have those, particularly when you're going to want to watch the progress over the course of the year, that we know what the date was and which classroom it is. I was a math coach for 4 years, and so I entered this data into spreadsheets. So as the person that didn't give some of these, it was nice to have this information all filled out so I knew who was the person that was administering the running record, what teacher did they belong to. I didn't know all the hundreds of kids, so that information was important. What we have here is the benchmark expressions. This matches up to that benchmark sheet. And what this is a little different than the original one. I put in the codings here. I put the automatic, the 5 seconds, and the prolonged thinking. Now, the 5 seconds is there not because of research, but because I found that there was a middle ground. There were some kids who automatically gave an answer, whether it was right or whether it was wrong. They just gave their answer. And then the prolonged thinking, there were some kids just taking a super, super long time, but there were some kids in the middle that were, within 5 seconds. And that to me is very different instructional response. Remember, these running records are totally about getting the information that we need to respond instructionally and to tier our guided math groups to meet the needs of those kids together. So we can group kids together who are doing similar things. And so I really liked having that middle of the road time-wise. So we have automatic 5 seconds of prolonged thinking. When the students give me the answer, I put a check mark if they got it correct. If they told me an answer that was wrong, I put an X that it was wrong, but I do put the actual number that they've said because again, the instructional response is different. From a student, I've had many young students who, when I asked them 2 plus 1, they said 21. Now, that's very different than a student who might say 4, who was trying to figure it out and was 1 off or something. So I did want to be able to mention on there exactly what answer that they had given. So again, I do the check mark if it's right and an X if it's wrong with the number that they said. You'll notice there's an extra code here that was not on the original ones. It's this IC. When I was giving this to kindergartners, I was finding that some of the students, even by the end of the year, still weren't recognizing the quantity based on the abstract, just seeing the number. So when they saw a 2 plus 1, they said, I don't know. So try putting it in context of a word problem or a situation that is familiar to them. So I said, well, what if, I use the same numbers, but I said, well, what if you had 2 cookies and I gave you 1 more? How many would you have now? And then they would say 3. So the same student who minutes before said they did not know what 2 plus 1 was able to tell me 3. Now, there also were some students that couldn't even do that. So again, it's the information I wanted to give to my teachers to know how to respond and make a plan of attack for those different needs. So that's the first part here. Dr. Nikki loves having the codes in these boxes. For myself, I didn't. I like having it just be blank. I found looking at the sheet, it was kind of complicated with a lot of words and all. So for me, when I created them, I took all these codes out. I mean, they're still there and I still wrote them in when I saw them, but I didn't like seeing all the codes there together. So that's why you have 2 versions. We have the version of the running record, then they're identical, but one version has the codes in those boxes and one version does not. So you can use whichever one you feel most comfortable with and what you like the best. But again, you would just circle those codes that was appropriate to the behavior of the child if you noticed it. So only if you noticed it. Asking them, what did you just do? What number did you start with? That's not the time for this. That's part 2. It's super, super important, but it's part 2. So we'll go through this top part. And when I do feel like the students are struggling, whether they're getting lots of answers wrong, whether they're taking really prolonged thinking, I just stop the interview. Because again, this is not for a grade for a student. This is going to be information that I can use to respond instructionally. So if I know where I want to begin working with them, I'm going to stop the protocol here on the front, and then on the back side, delve a little deeper into that place that they had a little slowdown and figure out what was going on, and they need to work on maybe the strategy before. Maybe they knew the strategy or the expression on this side, but when I ask more in that realm of the strategy, they don't have the fluency yet. So I want them to work there. So you can stop that whenever you feel the need. Over on the side, we have the codes, just in terms of that progression. And in this middle section here, we have those same codes that are up in the top boxes, but just explained out in words. So remember, there is that progression of development where students are going to be finger counting all. So if they're adding 3 plus 2, it's very natural for us to see 3 fingers and 2 fingers, and then we'll count them all up. 1, 2, 3, 4, 5. Now that's different than holding up all the fingers and knowing that this is 3 and counting on 4, 5. Also different from not even having the 3 and saying 4, 5, which is different from 4, 5, which is different from 5. See all those levels there. We want to be aware of all those levels because our goal is to get the students to the next step. We can't take them from step 1 and jump to step 20. We want to know what is the next level, and it's a progression of development for their brain. When they are ready for that, that's where they'll move to. So we want to provide those opportunities for them to build them to that next step on that progression. So that's why we're being aware of all those codes. If a student does self-correct, we want to note that. That will not count against them. We want to note that we'll know that they were able to self-correct. That metacognition is crucially important, so it's wonderful to know that they're self-correcting. Attempted self-correct, the ASC, that's if they tried to fix it, so they knew something was kind of wrong, but they still got the wrong answer. So that's an attempted self-correct. Down below here, this is the piece that is brand new. This is the instructional response. Where do I begin instructing this child? Now, in terms of the protocol itself, the backside was so full, I didn't want to break it up and put part of it on page 1 and part of it on page 2. So this part here, this general observation, is only to be filled out after the whole thing is done. So at this point, once you be able to figure out where you're stopping the benchmark expression questions, we'll go on to part 2. We'll go back to the beginning and say to them, okay, so what's happening when you add 0 to a number? Can they generalize? So maybe they know 4 plus 0 is 4, but do they know that when they add 0 to any number, that property of adding 0, that's going to be just the same number? So here's where we're going to get a sense of whether they understand the strategy or not. So I have put on the protocol itself a lot of the things that we're looking for that I found myself writing them down all the time, which just took time. So I wanted to put it on the protocol, so just check it off if they say it. So they either knew that's going to end up being the same number as the sum when you add 0 to any number, or they can't articulate that. Now, if a student's able to tell me 8 plus 0 is 8, 5 plus 0 is 5 without any thinking, it's just accurate and fast, then I would say but that yet they can't articulate why that is, that what happens when you do it to any number, because a lot of students will say, I don't know, and they just can't articulate that. That's going to be a response that I want to have in a small guided math group, and it may be that the students are working on different strategies, but I want to work on that articulating our thought, because that's really one of our math practices, being able to support our thinking. So really important skill, but in terms of them working on those set of math facts, they don't have to work on 4 plus 0 and 5 plus 0. They know what it is. So again, that's what I want to be aware of. So I've added this, do they know the strategy? Do they know that strategy? Do you feel comfortable moving them on from that strategy? And again, I would circle a yes if they tell me 8 plus 0 was 8 and 5 plus 0 was 5. If they couldn't articulate it, it's just I want to make a note that they couldn't articulate it to work on that at a different time. So I would put the yes there. Here are the levels again, the 0, 1, 2, 3, 4. That 4M is new, and then 4. And then we'll go on to what happens when you're adding 1 to a number. So you'll notice we have extra expressions within that zone that we want to probe deeper and make sure that they're all set in that strategy. Now, here is the only box that has 2 strategies in one. We have adding within 5 and then the adding within 10. Separated out, because I'm sure there are students in grade 1 who are still working on adding within 5 and others who are adding within 10. But we are looking in the strategy for some counting on. That's perfectly appropriate. You're going to be within the 3 seconds that we want. Hopefully you're accurate. Particularly, though, in this strategy, working on the larger number and the larger addend, particularly when that addend comes second. So 2 plus 6, research has shown, has been a lot of tricky for a lot of students, so that's why it's on here. So 2 plus 6, we want them to start at the 6 and count on that 2, rather than starting at the 2 and counting on the 6. So we want to work on that as a strategy. So just, again, games and activities and being able to see it, use lots of math tools, and build that concrete pictorial abstract progression for them to get to the point where that strategy is in place. Add, make, 10 is crucial. Add, make, 10 is crucial. It is the foundation of the number sense. It will help us decompose numbers, break them into numbers, into easier chunks for our brain, go into larger numbers, as well as fractions and decimals down the road. So that we need to have that skill of that making 10 to know automatically. And I am looking for that. I am looking for that automaticity of knowing the pairs of numbers that make a 10, particularly when the addend that comes first is the lower number. So these are in a particular order. So we're checking first, what's 8 plus 2, what's 3 plus 7, to see if they know that. But then I want to give you a number and what other number makes 10 with it. And I begin with 5 because most kids know 5 and 5 is 10. Then I go to the 9 because, again, most know 9 plus 1. Then I go to the 6. That takes out some kids right there. And then I go to the 2, and now I've lost my students who I know have not mastered the pairs that make 10. So I'll want them working on that. That's going to be the zone that they're going to be working in if they have everything else in place. So, so again, we have this no, yes, and emerging, because the emerging was there because I was finding students that maybe did it for one expression, but didn't do the strategy for the other expression. I'll talk about that in 1 second. So they're in an emerging or they're inaccurate. Maybe they had one answer right and one answer wrong. They're still doing the same strategy. Maybe it's like counting on, but they had 3 plus 4 equaling 8. And then 2 plus 7 was the 9. So they're kind of in that zone. So they're emerging. They have the strategy. Whereas a student who looks at it and says, I have no idea, then they don't have that strategy in place. So, so we have those there. The adding 10 to a number, I don't want students just saying I add a 0. That's not mathematically, appropriate. Not appropriate, but it's not mathematically development to show that they're understanding that every T number can be broken apart into a 10 and some 1s. And I want to work on that articulation of that place value understanding. So if they know 10 plus 2, 12, 10 plus 8, 18, I wouldn't make them work in the strategy. I'm going to make a note that I want to pull those kids aside to work on the understanding of it, or at least I'm aware of that during my time with the kids. When I'm in a whole group lesson with the kids and someone mentions that, I want to work on that articulation of that. Now we have our doubles, and I do want automaticity with those because these are the building blocks for these strategies down the road. So checking out each of those pairs of numbers that are within the teens. And do they know if they call them doubles facts or not? Again, I wouldn't hold them back if they don't know it's called doubles. It's just my awareness as the teacher that I want to make sure I get that word out there with them. Now, here's where I find the big separating place. A lot of students, the vast majority of students, know 5 plus 6 is 11. And when I ask them why, they say, well, 5 and 5 is 10 and 1 more is an 11. That benchmark of 5 is so strong. So they know that. And 5 and 5 knowing that that's 10. But then I ask them 6 plus 7, and they will count on their fingers, or they will mentally try to count on. That's where I know they need to work on the strategic strategy of doubles plus 1. Now, at that point, that's the first really foundation of strategic thought going on in terms of breaking apart numbers. I know that I want them to do down the road. My biggest strategy that I want them to know is that decomposition of bridging a 10, because that will forward itself to larger numbers to do the nearest 10. Like if I'm doing 38 plus 7, it'll be the nearest 10. Or if I'm trying to do some larger numbers, even in 3-digit numbers, I'm trying to add those numbers together. And then fractions and decimals as well. So it's really the foundation of their learning that's going to be right along their journey with them. So now let's say that a student, though, told me that 6 plus 7, maybe said it was 13 because they broke apart their 7 to a 4 and a 3, because 4 and 6 make a 10. Or the other way around, they broke apart the 6 into a 3 and a 3 because 7 and 3 makes a 10, and then 3 more that they the 13. They are doing the golden strategy. So I am not going to make them work in doubles plus 1. Now, do I not want to have that exposed that will come out in my number talks that I do with my visual dot patterns on the board as other students think in that way? But I'm not going to make a student work on those set of strategies, practicing a doubles plus 1 strategy when they are doing the golden one, the one that will get them the furthest on their math journey. So that's why I have on here some other things, because the students can do whatever strategies work best for their brain. I am not going to force them in these strategies. It's just that this is a nice gateway strategy to get them into thinking about breaking apart numbers to make it easier for our brain. So, so again, if they do 6 plus 7 and they're using counting on by 1s, I want to introduce them to the idea of the doubles plus 1 strategy. But if they're breaking it apart to make their 10, they're zooming to the end. I'm not going to make them work on those. We never want to dictate a strategy to students. Okay, so when we get to the end here, Part 3, super important, the math disposition. Part of my reasoning of making this new updated version as well was to get it down to 2 pages. I know that this Part 3 is super, super important. We need to have that on there of kids' math disposition, because research has found that the more students believe that they can grow and learn, and in fact, research has shown that's true. All of Joe Bowler's research with growth mindset, the more they're going to achieve, because they're going to believe in themselves and have confidence, not be afraid to make mistakes. They're going to make their chances. They're going to be learning and growing, having those synapses firing in their brain and making new connections. So really important to ask these questions here, get a sense of our kiddos. Here are the codes again, with the explanation of those codes again, plus the 0 to 4 explanation. Now, once I'm done this, now I'm going to look back to this backside and I'm going to see which strategy was the first one that said either emerging or no. That's where I want a student to work. So I go back to page 1 on the bottom here, my general observations. Again, I'm done my interview now. Now I'm writing out where do I want to begin working with this child. I will have the focus areas, because some students don't need to work on certain aspects of these 3 parts to the fluency. So I want to circle exactly what does that student need to work on, because maybe some of them are already solid. Maybe they're accurate. They're just super, super slow. Well, I want to know. I want to work with them on their automaticity, whereas their accuracy is fine. So it depends on the student. Again, they're all different. Here is the strategy to begin the instruction. You have them listed out here. Just circle the one that they are going to begin to work in, because people entering the data, whether it's the classroom teachers or a math coach in your district, as for me, when I got these protocols, I typed that code into the data file. So this is the code that I want them working in. So circle the one that they want to work on. And then for that strategy, what was their level? I want to be able to know as an interventionist, okay, this student needs to work on doubles plus 1, and they're currently at a level 1. They're using fingers. So then I know I can plan my instructional response to work on trying to get them away from counting on their fingers, using visual patterns, the key of making that visual pattern in their brain. Now, so I want to be able to know when I work with this child exactly where I need to begin on that progression of the fingers and mental and derived facts and getting that automaticity. So when you're, again, circling the strategy that they're working on, and then exactly where was that level in that particular strategy. You're not giving an overall code, because of course kids do different things with different strategies, right? So they might do a counting on with one thing, but then they're doing the derived facts with another, and they're within the same strategy set of numbers. So it's what that strategy is, and then make a note of that as well. So if a student is finger counting on, well, were they beginning with the first addend, no matter what it was, whether it was the smaller number or not, or did they begin with a larger addend when it came second, to be able to do that? So again, this is going to be allowing us to really zoom in instructionally and have that instructional plan. That way you can enter that into a data spreadsheet, and then you can group kids together and work together on that and progress them on their journey instructionally. So that is the addition running record. Please feel free to add in any comments or questions that you have as you go. But have fun, find a student, and just get going. Take care.